Hello, everyone. Today's session is about introduction to Elastic App Search and Web Crawler. This is Animesh Bansriyar. With us, we have got Markus Klose. Markus helped put together all the content, and he was very kind. I and Markus both the solutions architects based out of New Delhi and Germany, respectively. I will head out, head on with the presentation. The idea is how to build a great website search. From having no search to go on and build great search, what are the different parts that are involved? With Elastic, we have been working with search solutions since a very, very long time. So for us to be able to define particularly well how we go from no search to having great search on a particular website, these are the following things that are of key importance. First is identifying the right core technology. With Elastic, obviously, we have got Elasticsearch and Kibana, which are the building blocks for building our search. And then we have got other building blocks, which we'll be talking about shortly. Talking about the Elastic stack, we have got Elasticsearch, which is a very popular search engine, or perhaps the leading search engine that is around. It is also used extensively as a NoSQL data store. We have got Kibana, which is a visualization and management layer. And we have got a few ingest tools, for example, Logstash, which is an ETL tool. This is the oldest ingest tool that we have. We have got a family of beats, which are lightweight data shippers, which help ship a variety of data from nodes which need to export data onto the Elastic stack. Lately, we have got Elastic Agent, which is a culmination of all these efforts. And this is one single agent to rule them all. So on top of the Elastic stack, we have got a few solutions that we have been working on. These are the solution areas that we have. We've got enterprise search. I'm going to talk a little bit about a specific part of enterprise search, which is app search. Then we have got observability solutions. We've got log analytics. We've got metrics. We've got Elastic APM, and we have got uptime. With Elastic security, it is about having an Elastic endpoint and Elastic SIEM, how we protect users considering both these two utilities. From a deployment perspective, we've got a variety of offerings that we have. The most natural fit is Elastic Cloud, which is a SaaS platform, which we run on the three major hyperscalers, which is Azure, GCP, and AWS across multiple regions across the globe. We also have a couple of orchestration platforms. We have got Elastic Cloud Enterprise, and we've got Elastic Cloud on Kubernetes. Elastic Cloud Enterprise is a proprietary orchestration platforms which let you manage your own internal cloud and multiple Elastic clusters at scale. Same thing for Elastic Cloud on Kubernetes. If you use Kubernetes in your organization, ECK or Elastic Cloud on Kubernetes lets you manage, scale, run multiple Elastic clusters on top of that. Saying that, about Elastic Enterprise Search, we have got App Search and we've got Workplace Search. App Search lets you build rich user-facing search applications, either on your mobile applications or either on web application. We provide a full set of APIs, web tools, etc., to be able to do this. Workplace Search is all about being able to search across all different organizational data that are there, whether it is email or whether it is something like Confluence, whether it is different data in SharePoint or what have you, all that can be searched by using Workplace Search. The focus for this particular talk obviously is App Search and how we can quickly get started. So once we have identified the core technology to be Elasticsearch or the Elastic stack, the next phase obviously is to find out how we ingest data. Now, one thing to remember here is App Search is an attempt to make it easy for our technical and non-technical audiences. With Elasticsearch, there's a lot of attempt or a lot of complications, or there's a lot of effort involved in building out a search application based on vanilla Elasticsearch. With App Search, we just want to make it much more simpler. When we talk about content ingestion, the first step over here is obviously the web crawler. We also provide various APIs and client libraries and what have you to be able to ingest data particularly well. Now, if you focus on the web crawler, we have got, it's a fairly new part of Elastic App Search. We provide entry points to tell the web crawler on where to start the data crawls. We have got definitions for sitemap, which you can input. We have got variety of crawl rules to allow and disallow certain content to be done. Again, so we also provide a lot of other controls, for example, crawler meta tags to specify what kind of content do you want to ingest. We can override the engine schema with respect to defining the right meta tags. We have a lot of inclusion and exclusion rules to make sure that the correct content is actually ingested while using the web crawler. We also have a way to manage how the data is crawled, whether the data needs to be crawled every hour or every few hours or every few days. All that can be done fairly seamlessly by configuring the right cadence. We can also define whether to override the content or whether to add that as new content, etc. So those controls are there. We will anyways be building out more controls in the recent future as well. Talking about how and what we do when we crawl. So one thing that we do after crawling the data is to make sure those actions are captured as a part of the stack. This is where a log analytics platform or the capabilities of having log analytics as a part of the Elastic Stack plays an important role. We are able to easily identify what content is being is ingested, what is being crawled, if there are any parts of the website which is being denied, etc., etc. We have two ways in which you can do that. We have got the Discover tab, where you can go and build your own views on how you want to see the data. You can get into the JSON level or look at the JSON of each and every document which is being ingested. We also have the logs UI, where you can easily stream in real time how the crawl requests are happening. The next phase, once we are able to identify what content is being ingested and how it is ingested, is to handle the UI and the UX correctly. We provide a bunch of utilities to be able to do that. Of course, there is a search UI component, or we have got a search UI library, which you can download from Elastic App Search or define it yourself, which would be able to define what kind of search results you want. Whether you want certain fields, you do not want certain fields, all those can be defined by tuning your search results. Similarly, autocomplete is a part of UI UX experience that your users would be seeing. We also need to make sure that the filters and facets are correctly defined. And then obviously we can move into the search control, but talking a little bit more about how the UI UX would be. With search UI, as I said, it lays the groundwork and makes building search experiences easy. This is available from a GitHub page. This is something that you can download from our app search UI as well. So during the demo, I'll be covering on how search UI can be configured correctly and how it can be downloaded to be used as a part of your web applications. Once that is sorted out, we talk about the search controls. There are a variety of search controls that are available. This is to make sure that we provide the tools to our users to be able to configure the relevance or tune the relevance as per the requirement. No search or all searches are not equal. Every search is different in some way, and that's why these controls are important. The analytics help provide a proper feedback loop on what the users are doing. We can add other components or other modules to make it much more relevant. But it is important for businesses and even our product owners to understand what are the queries which are getting the maximum clicks and variety of analytics on those lines. Same goes for relevance tuning. We should be able to make sure that the relevance is properly tuned and so on. This is an example of how the analytics dashboard look like. We obviously also provide APIs, as I probably have not mentioned before. Elastic is an API first company, and we always build API first before we add to our user interfaces. Then the next thing is, this is a screenshot of how you can tune relevance. I will be showing you how we do that during the demo that I would do. But the idea is to give a lot of controls to technical and both non-technical users to be able to immediately be able to tune search relevances whenever the need arises. We can also add synonyms, we can add curations and so on. So these are certain things that are there. While we won't be able to cover all of that during the demo, we do document them enough, and we also have other sessions and recordings on the website, which would help you get started if you want to get into curations or get into how to use the query UI and so on. On top of everything, so the first thing that has to happen when using app search is to create engines. So an engine could be more related to a part of the website. So if you have got multiple different engines which would cater to different parts of the website, they might be related to how different teams own the responsibility of this different website. We also can have meta engines which help put all of them together and provide one search. The easiest way to talk about this in more relevance would be, for example, there's a document site on your particular website. So there could be an engine for that. There could be one blog site, which could there could be a different site, different engine for that. There could be a different engine from your primary website. Now, if I have to provide a search interface on top on the homepage of your website, all I have to do is define a meta engine, bring all those engines under this meta engine, and voila, we have a search engine for all the content that is there on the site. So this is the end of the few slides that I had. This is a high level capture of what we have about Elastic App Search and how the web crawler helps us get started immediately. I'll quickly jump over to a demo at this point of time. So we have got Kibana here. We have got Elastic App Search here. So what I'll do is start with the App Search interface. These are again running on Elastic Cloud. I can show you, or I can get into how to create a small cluster out from scratch, but we do not have that much time. So that's why I'll get into App Search directly. So let's go ahead and get into the engine. So let's create a new engine upfront. The idea is that we would create an engine for the blogs that are there on Elastic Blog. This is probably a common example that you see on all the content that we have. Elastic Pro blog/test, something like this. We have a variety of language analyzers that we have. For this, we will select Universal and get started. There are a variety of ways in which we can add data. Obviously, we have got uploading in JSON file and pasting in JSON, but for the purposes of this demonstration, we will use the web crawler. This is where we would validate the domain. You can see that if there's a validation which happens, everything is passed. It just finds the robots.txt and says that there are certain aspects of the site that we cannot really crawl. I'll add this domain. So then we get into managing how we configure it. I'll add another entry point for our blog here. So that's elastic.co/blog. I'll save it. I do not need to add any sitemap because we do have sitemaps already on our Elastic website. I have kept this open in a particular tab to show you. This is the robots.txt, and you can see that we have got a variety of sitemaps out here. So there's no point to add a sitemap. The robots.txt will be parsed, and the sitemap, all the sitemaps will be considered. If you can see the crawl rules, you can see that there is one allow for all sites, all pages that are there. We can add a particular crawl rule, say that, well, allow contains/blog. I have made it as contains and not to start with, because often what happens is for different language blogs, for example, if you're talking about French blogs and German blogs, they would have an /fr or /d and so on. I'll go ahead and save this, and I will add another crawl rule, which will essentially disallow all the other pages. So I'll just add a regex out here saying .star. Click save, and there you go. So what I'll do now is go ahead and start a crawl. I can see that the crawl finished. You can see that it's already over. So perhaps there's something wrong. I'll go and see if there is something I can identify. So this is Kibana. I'll do a quick refresh to make sure that I'm logged in. Looks good. I'll jump onto the Discover tab. This is for metrics. I will identify the particular index pattern. Just make sure that this index pattern is available. This is a hidden index. So if I need to show you what this index pattern looks like, I'll go to stack management. I'll go to index patterns. I would show you that this .end search crawler is the one with various fields that I have. So note that this has to be created. This is not something which is out of the box. And this is from the hidden system indices. Now, if I go back to the Discover tab, this is what I see. I see that there are only 15 pages which were indexed. Now I want to see what actually happened. I can get into the JSON, but let me find something which is more straightforward. I have a saved search that I have out here. So I have an app search crawler logs, which is the saved search, which would give me a better view. So this is a view that I built earlier. For people who are used to Kibana and know how the Discover tab works, you can anyways add the fields over here and see this from your view. So we've got timestamp, URL domain, URL path, event action, and we've got response code. I see that there are no response codes here. I can add details on what actually happened. I can also do the same from looking at the logs app. So let me jump over to the logs app. So what I did earlier today is configured the logs app to show data in this format. Obviously, the default is not like that. It is very simple. By changing the settings, you can add which column you want and so on. So you can see that there are some rule denied exceptions or rule denied reasons that are there out here. So what I'll do is, sorry, this is 2023. I'll jump into the stream live. Yeah, this is the latest one. I see that 2152, which is time in India. I see that there has been a rule engine denied. So what I'll do at this point of time is go on to Elastic App Search and check if everything is fine. So since I know this, and this is something I probably added to show how it actually works. What is happening over here is the first rule that is being executed is a disallow rule, which is disallowing everything from being crawled. And the second rule should actually be the first, and the disallow should be the second one. So I'll just move them around, and everything should be fine. What I could do is go ahead and start a crawl right now. Okay. I just started the crawl. It's in pending state. Okay, looks like things are working. Let's go ahead onto our Discover app and see if everything's fine. I'll just quickly refresh. Yeah, I can see that more requests are coming in. I see that there are about 1,000 odd requests that are coming in here. So it looks like there are certain things which are happening. You can also see that there are certain URLs which are being crawled. Some of them might not be, indexed. Some of them would be indexed. If I head over to the logs app, I can see more details. There you go. I think we are seeing a lot of denied, failed, etc. And this is quite natural because we have only enabled some part of the site to be indexed and some others to not be indexed. So if I run a search over here in the search bar about what is being indexed, yeah, I can see that there are certain documents which are being indexed into the app search. So we have got a few messages coming in, index the document with a particular doc ID and so on. So this is the actual URL path that we have. Now, when our app search is working fine, we have got everything going. If I go back to overview, I can see for myself how many documents have been ingested, what actually is happening, and so on. So I see that there are no analytics, no operations, etc., because the data is being ingested. If at this point of time, let's go ahead and find out do a few searches. So for this, so that we could do a proper demo during this session, what I've done is I've indexed the same thing prior uh, to this conversation as well. I've got Elastic blog. If I see out here, there are certain number of documents. I fired a few queries before, and you could see that that there are some API events which are there also. So if we go into how the documents look like, so these are the kind of documents that are there. So we have got these documents which are there. I could do a few searches. Let me do one thing. Let me jump over to relevance tuning and see what we have out here. So I'll do security as an example. I see that I see that something which is German content has higher boosting, higher scores. So this is because I boosted that earlier. So URL path there contains contains a language code out here. If you want to see the full document, you can expand it. So these are the different fields with the values that are there. The content obviously is not shown, but everything else is shown out here. So we do have the content, but initial snippet of the content. If I go to URL path tier 1, you can see that there is something out here. If I edit it, you can see that there's a boost which is being added. So if I change this boost now, I could say, well, I don't need German content to be on top first. I would need French content. So that's what I do. I click on save, and I can see that it has changed to the French content. And what I can also do out here is just remove it altogether. If I will just delete this boost. And click on save. And I can see that the score has changed and we are getting something entirely different. So you can see how you can tweak the relevance by doing certain things like that. Same thing I could do for a lot of other parameters. If I can boost, say, domains or title for everything for them. If I go into result settings would basically be what are the fields that I want my results to contain or to carry. So I can enable disable from here. So I'll just leave it as they are. So let's go ahead and run some queries and look at how the search UI would look like. So this is our search UI. This is the place where you can build or generate a search experience. You can see that there is an option to provide the title field. There are certain options to filter fields. So if I, for example, use that same URL path there 1, which is the language as the filter, and then what I can do is filter something like URLs as well, for example. This would be the top level URL. And then you can have a few sort as well. Say, for example, something like ID and something like title, for example. And we have the URL field as optional. And we'll just go ahead. All we need to do is just go ahead and click on generate search experiences. This is very similar to what a vanilla search experience would look like. Obviously, if there are correct CSS and everything, it will look different. For this to be adapted to your particular website should be fairly straightforward. You can see that we have got the filters of the facets already on the site. We've got these different filters. If I just want Japanese content, I'll just click on JP. And I can see that all we have is here are the Japanese content. I could also say that I just need the first blog URL. So this is what it is. If I remove it, I can also see what are the different sorting mechanisms that we have. We can sort by ascending by ID, by either ascending or descending, same for title and so on. So this is an extremely seamless way to generate the search UI, which can be embedded. If you see on the right-hand corner, you can download the relevant files, which can be incorporated into your web. So if I go back to my Elastic App Search, if I can now see the overview, you would see that things have changed a little bit. We are seeing a lot more number of queries. If I want detailed analytics, I can go down further and I can see that there are analytics about top queries, if there are any clicks which happened post those queries, and so on. So this would help our users to refine their search experiences further. So the last thing before I log out here is meta engines. You remember that I talked about meta engines during the course of the presentation. So the idea is to have a particular meta engine to cover both our Elastic blogs and the Elastic website. So I'll just do an Elastic Pro meta. This is a meta engine, and I'll add both the blog and our primary site and create a meta engine. So you can see that these are 95,000 documents. If I go back to my engines, there are 87,000 and almost 8,000 documents in these two different engines. And meta engine is a summation of both of these. We can treat the meta engine the same way as we do to other engines. For example, be able to tune relevance and so on. So there are other things which are also exciting about app search, for example, defining synonyms, defining curations, and so on. So all these I would leave you to discover them either on your own or on our website. So thank you. This brings us to the end of our presentation.